Good afternoon. My name is Paul Ashurst, and I'd like to present to you weight-saving opportunities with polypropylene compounds. Before I do, I'd like to give you a brief introduction into our company. LyondellBasell is one of the leading chemical companies in the world, with operations on 5 continents and sales in more than 100 countries. We have annual revenues of $44 billion, and we have approximately 13,000 employees worldwide. So quite a big company. Our products go into quite a diverse range of end uses, and let me just walk you through our business segments. Olefins and polyolefins. We are the largest producer of polypropylene in the world, and that's why we're here. We're also the largest producer of polypropylene compounds. We're a leading producer of polyethylene, and our products go into automotive fuel tanks, bumpers, interior trims, instrument panels, as well as other household items and consumer goods. Intermediates and derivatives. We're a leading producer of styrene monomer, propylene oxide, which go into applications such as antifreeze, insulation, and adhesives. And refining. We have many refineries around the world where we refine gasoline and diesel, which go into aviation, automotive fuels, engine oils. And our final business segment is technology. In simple terms, we produce our own polypropylene and polyethylene using our own technology. And this has won us 2 Nobel Prizes with our predecessor companies. We also license this technology to third-party companies. So if there's a new polypropylene being built in the world, then there's a very good chance it's going to use our technology. This is an overview of our PP compounding asset footprint. So this is where we take the PP and we add talc and reinforcing agents. And this represents over 1 million tons of capacity. It's the largest capacity in the world, and is predominantly for automotive materials. It also represents our strategy in that we like to be close to our customer. Wherever we have a plant, we have local TS and local sales. Also, what this gives us the opportunity to do, which our OEMs and Tier 1s really demand, is the ability to produce global materials. So if you have an approval here for a material for Ford in Turkey, and you want that same material in Brazil or in China, then LyondellBasell has a very close team, a very close network, and we're able to really transfer that information and produce those global materials. So what is driving weight reduction in our sector? What are the key factors? Well, the European Union is committed under Kyoto Protocol to reduce greenhouse gas emissions. CO2 targets of 130 grams per kilometre by 2015 and 95 grams per kilometre by 2020 are legal. And transport's been identified as the worst performing sector. About 1/8 of CO2 emissions in Europe are down to cars. And high oil and fuel costs have really driven OEMs to further research alternative energy sources, such as fuel cells, hybrid technology, and batteries. Lighter vehicles are going to help car manufacturers avoid those costly penalties and also help in the future for battery-driven cars. So how are the OEMs progressing towards the 130-gram target? Please remember, this target is an average for all OEMs. So if you produce smaller cars, then the target is below the 130 line. And if you produce bigger cars like Daimler and BMW, your target will be above the 130 line. Most car manufacturers should meet or exceed that target by 2015. Currently, there are about 6 OEMs who are not on track, but seriously, they should achieve this. It's a relatively easy target in some respects. The 2020 target is going to be a lot more difficult, and OEMs will have to increase their rate of progress in order to meet those future targets. However, one of the underlying issues is that cars have been getting heavier every generation. This chart shows the curb weight over the last 20 years of cars in Europe in different segments. And this is due to increased consumer demand for more spacious interior, increased safety content, and increased feature content. When the Mark I VW Golf was launched in 1974, some of you may have had one, it weighed 750 kilos. When the Mark VI Golf was launched, it weighed more than 50% more than the original car. However, things are starting to change, and the Mark VII Golf recently launched weighed 100 kilos lighter than the Mark VI, despite being slightly longer and slightly wider. And this was due to using higher strength steels around the body area, the body structure, and also the seating area. Mercedes-Benz C-Class, recently launched, was actually lighter than its predecessor model, and Mazda introduced a new gram strategy, where they looked at every single part in the car and decided how they could take weight out for the next generation of vehicle. And this is Mazda 2, launched in the USA, reduced by 100 kilos compared to the previous car, which is quite an astounding amount considering this is a B-segment car weighing only 1,000 kilos. So where does polypropylene fit into this mega trend of weight reduction? Well, polypropylene is one of the most versatile polymers. It's also one of the lightest polymers. So it's a very low density material. And that's why it's so popular. If you look at this chart behind me showing the application areas of automotive, you can see that polypropylene is the dominant material in most application areas. It also has one of the best cost-performance balances. And cost, as you all know, is one of the most important physical factors. And through compounding, adding talc and elastomers and reinforcing agents such as glass, we can really extend the property profile of polypropylene. From the elastomeric materials for car bumpers, by adding talc, we move into interior trim areas and instrument panel applications. And if you look to the left, by adding glass fiber to PP, whether it's 20, 30, or 40%, we can really increase the modulus to levels of over 9,000 megapascals. So now we're really starting to challenge and replace engineering thermoplastics and metals. So what I'd like to do is really cover those trends we see across Europe in terms of weight reduction. It may be simple density reduction by reducing the filler level. The foaming of PP is really snowballing. We see a lot of new projects. Thin walling of parts continues. Structural applications, replacement of engineering thermoplastics, as I've said, and metals. Body panels is an area of growth. And we've got some nice examples of exterior metallics. We'll touch on some new areas, the progress of our Softel interior trim materials, green solutions to weight savings, which is natural fibers, and also our latest technology, which is plastics interface technology, which we call PIT. Toyota, and indeed the Japanese OEMs, have been the pioneers in thin walling or down gauging. Of course, if you reduce the thickness of the part, you have to increase the flow of the material. And because the part is thinner, it means you have to increase the modulus of the material to achieve the same relative rigidity. We supply this material directly to Toyota France for the Yaris bumper. It offers weight savings of about 15% compared to conventional talc fill materials. We're also supplying this material extensively here in Turkey for the Toyota Verso and Corolla sedan exterior trim parts. And high-flow, thin-wall materials don't necessarily need to be for large exterior parts. This is an example of our latest Renault-Nissan material, meeting the AS2 spec. It combines the French excellent low-odor material, good scratch performance, with the high-flow, high-rigidity Japanese style. This material has an MFR of 18 and flex mod of 1800, and again, it's for the instrument panel and provides weight savings of approximately 15%. This material is nominated on the next CMF1 platform, which includes the Laguna, Espace, and Megane, and it's currently on the Nissan Qashqai instrument panel. Density reduction. This is quite a simple idea, but we've been able to achieve this density reduction of 8%. This is an example of two VW materials. The first example is 20% talc reducing to 10% talc. And the second example is 16% talc reducing to 5% talc. Of course, with the talc reduction comes an improvement in the scratch performance, but also we've been able to achieve this as a drop-in solution. So it fits into the same tool with the same property profile. And we're able to do this by using higher quality talcs and also our own process technology polymer. And just look at the effect. By moving those two materials to the new materials, on the VW Polo, the weight saving is 2.7 kilos. And if you imagine multiplying that through many parts and many more cars, you can see that a simple density reduction through talc reduction can have a significant effect. Body panels is an area of growth, as we've seen already. We're supplying the material for the outer panel and also the roof spoiler. What are the requirements? Low CLTE, so we're talking about low shrink materials, and that's because these polypropylenes shrink quite a lot, but they're in contact with steel, so you don't want to create any gaps between them. So this is a 30% talc-filled material, so it's relatively low shrink. And these materials also have to have no flow lines visible and no sink marks visible, because most of these parts are painted, so you have to have a Class A surface finish. This material is high rigidity, easy flow, and our CAE engineers based in Italy worked very closely with our customer to achieve a really superb surface finish. This is the Nissan Rogue in North America. It won the Society of Plastics Engineer Award for innovation. This is the same car as the Nissan Qashqai in Europe, and this is the tailgate outer panel. It's the first fully polypropylene liftgate using our material. So this is not concept, this is not future, this is happening now. And the material, as we've seen before, gives a 30% weight saving. This material, again, is really high flow for thin walling. So it's MFR of 40, and it's got a flexural modulus of 2000. And it's not just tailgates. This is an example of polypropylene, a low-shrink polypropylene with good rigidity and high flow for the Daimler Actros. And this is the whole of that front trim in polypropylene. This has been a trend you've seen of panoramic sunroofs, traditionally made of glass. What that does is it raises the center of gravity to a higher position, and you don't want that for car stability. So one of the ways to counter that is to use one of our glass-filled polypropylene. And this is really replacing engineering thermoplastics and steel. So this part actually fits around the sunroof as a replacement for steel. These are some nice examples of a growing trend I'm sure you've seen in Turkey and across Europe, these metallic effect materials. These traditionally were painted metal or painted engineering thermoplastic. We've developed materials with fine aluminium flake and coarse aluminium flake, which means it's a one single-step injection molding. It's within the polypropylene. And we've developed these materials so that it meets the same shrink, so it's a drop-in solution. Examples here are the Range Rover Evoque in two separate colors, BMW X1, X5, and X6, the new Suzuki SX4, and the rear valance of the Ford Kuga. So these aluminium effects are becoming really popular. It's a very good way to freshen an old car, or for a facelift car, or for a sports model. One of the major issues of polypropylene in the last 20 years has been trying to achieve very good scratch performance and very low gloss. Our range of Softel products is the answer to that problem. Developed recently, it's now replacing painted parts, particularly PC ABS. It doesn't matter if you choose a fine grain or geometric grain. The gloss level compared to traditional polypropylenes, talc-filled polypropylenes, is much improved. And also via the Ericsson scratch method on the right-hand side, you can see in the blue, the Softel material has much, much improved scratch performance. We're supplying this material as a replacement to Audi A1, A6, and A7, replacing directly painted PC ABS. And this is one injection molding material without any secondary steps. We've also recently replaced on the Toyota Verso in Turkey, the glove box door, which was painted PC ABS, we've replaced with this Softel material. Again, it's a single-step material. Just a couple more examples. PIT is our latest technology. It stands for Plastics Interface Technology, and it's a way of permanently bonding together two materials. And we actually license the technology, so it doesn't have to be a polypropylene, but we license the technology. This example shows the engine cover for a Daimler E and S class. It's got a 0.2 millimeter aluminium foil, which is lacquered in a stainless steel finish, so it's replacing a steel type effect, so a big weight saving. It's sent to a preformer where it's cut into shape, the foil. It has an adhesive on the underside, and it's sent to the injection molding company. In a magazine next to the molding machine, a robot picks up the foil, puts it into the cavity, where it's held by vacuum holes, and then the polymer is injected under high heat and pressure, and a physical and chemical bond is formed. Now, we're quite excited by this new technology, and this material will be 40% glass-filled. The black material will be 40% glass-filled PP, replacing nylon next year. But it's not just aluminium foils. There's a whole range of new foils we're looking at, and we have 21 patents pertaining to this new development. One mention of foaming, we have developed a whole range of foamable materials in Frankfurt for interior trim with good aesthetics, low odor, and good scratch performance. And the only thing I want to add to that is that we have invested in a new tool which will be available, a breathable tool, which will be available from Q2 next year in our Frankfurt Development Center, where we can extend our knowledge and know-how with our customers. And finally, we've evaluated many natural fibers for green solution, and we found that cellulose is one of the better options. So we've actually had odor tests passed by VW. The properties themselves are similar to talc-filled products, and it represents a weight saving of 8%. That's a lot of information to cram into a 15-minute presentation. I thought it was 20, but hopefully you've seen from what we've shown, we have so many new ideas, current commercial ideas that we're selling today. And we'd like to not only challenge you, but invite you to join us in new projects. We'll be outside, obviously, later. I think most of you know LyondellBasell. And even looking at some of these ideas, we expect to save in the region of 10 kilos per car, which results in a -1 gram CO2. As you can see on the right-hand side, whilst all OEMs are expected to achieve the 2015 targets, the 2020 targets are going to be much more difficult to meet. And who knows thereafter, there's talk about 2025 targets being even lower in the region of 60 to 70 in terms of CO2. So we've started a new initiative of Save 10, where we look to save 10 kilos. I'd like to thank you for your attention and have a safe journey home. Thank you very much.